Welcome to this video. In this video, we are going to discuss how a car battery charger can be constructed easily and how it works. The car battery charger explained here very simple and effective one to charge a discharged car battery. A 12-volt car battery is shown here to be charged with this battery charger. Normally, the 12-volt car battery will be 40 amperes capacity to 100 amperes capacity will be used. When it is in discharge condition, it should be charged with appropriate and correct car battery charger. This is an efficient circuit design to charge this 12-volt car battery. This 12-volt car battery is being charged with the help of this circuit. The vital component of this charger is power transformer. The 230-volt main supply is being reduced to low voltage 14-volt AC supply through this secondary windings of the transformer. AC voltage is being made unidirectional, that is made to DC current through this silicon controlled rectifier, which works as a rectifier as well as a controlled circuit. This charges the car battery through the help of this fuse and that 1 ohm nichrome wire in series in the circuit. I will explain these two items later on. Where this car battery charger, this silicon controlled rectifier charges this discharged car battery slowly and regularly through steady level. When the car battery should be charged at an optimum level and should not be overcharged. So when the battery is fully charged, the charging current should be cut off through this silicon controlled rectifier. For this, a control circuit has been included here. The BC148 transistor along with this resistive bridge. This transistor is in cutoff condition when it allows the silicon control rectifier to pass the current to charge fully. When the discharged battery is connected to the circuit, the low voltage doesn't allow the transistor to conduct. As such, the silicon control rectifier is also is in optimum level and it will be charging through the series circuit. When the battery is being fully charged, the voltage appears between these resistive R4 and preset and R3 that gives to the base of this transistor BC148, which triggers the transistor to cut off this silicon controlled rectifier through the gate circuit. Thus, when the battery is fully charged, the charging current is stopped. So the battery is being saved through this control circuit. Hence, the overcharging battery is being controlled through this control circuit. However, a small trickle charge is being passed on to this 12-volt battery to keep it an optimum level of charging. That is available through this 220 ohm 6 watts resistor and through this rectifier. A small trickle charging current passes through this battery and is being kept. It may happen when the dead battery is being dead battery, that is fully discharged battery is connected to the circuit, it destroys the circuit. To avoid this this happen, a 1 ohm nichrome wire resistor is connected in series along with a glass fuse of 3 ampere rating to safeguard the circuit as well as the battery. Hence, this is an optimum circuit for car battery charging, and one can easily assemble it on any barrow board and can use it. This is a practical circuit, and one can assemble it and enjoy the full car battery charging. It all depends on the car battery rating as well as the circuit and diode rating. Diode ratings are based on this what type of the car battery is being used for charging. So you should be considered when this car battery rating the value. Thank you for watching. Thank you. Please subscribe and share with your friends. Click like. Thank you.